Okay, another important topic covered in this chapter is the net force diagram. And what that is basically summing up all the forces that we know are acting on a body and seeing if they add to zero, then there's no net force, and if they don't add to zero, there's a net force and therefore an acceleration. Right? So our Newton's second law, the net external force is mass times acceleration. So if there is a net force, there is an acceleration. And conversely, if we know there's an acceleration, there has to be a net force. If we know there's no acceleration, the sum of all the forces has to be zero, right? This net just means sum. It means if we sum all of the external forces acting on an object of mass m, whatever that sum is will relate to our acceleration. So to construct a net force diagram, we first have to construct the free body diagram, because that's how we identify all the forces acting on it. Then we copy the force arrows from the diagram in sequence, doing just our tip-to-tail addition of vectors. And it doesn't actually matter what order we do that in. And then we draw a double line arrow to show the vector sum. Okay, so here's an example of a skier going down a slope, right? So if we drew the picture here, we have the person with their ski poles and the skis going down the hill. Okay, so of course the hair's going back because they're going fast. Okay, so what are the forces acting on this person? Well, we have the force of gravity going downward, right? So we draw that from the center of mass downward. We have the normal force that arises. So maybe we should actually, let's take a step back and do this interaction diagram. Oops, I think I'm writing over where. Okay. Alright, so the person is interacting with the Earth with just a long-range force of gravity. And then there's also a contact interaction, which is has both a normal component perpendicular to the surface, right? That's what this is. And then there's also friction that's slowing the person down. And then we could say as well that part of the Earth is the air, right? And there's a drag force or friction between the person and the air. And that's what this is showing. Alright, now let's see if I screwed this up here. Kind of did. Alright, so for the net force diagram, then we're just adding one force at a time, doing tip to tail. So here's the force of gravity. That's the force of the normal. That's either the kinetic friction or the drag. And that's the drag. And then we notice that they don't actually come back to where we started, right? So there is a net force, which is shown, we draw here with this red arrow. So let me just do that again away from my interaction diagram. So here's our force of gravity. There's the force of the normal. We have some force of kinetic friction, force due to the air drag, and then we go from the tail of the first force to the tip of the next one to see what the net force is. We draw it as a double arrow. So we can see from the net force diagram the person is experiencing a net force down the incline, meaning that they will also be accelerating in that direction, right? Where acceleration is again given by Newton's second law, the net force is mass times acceleration. Okay, so here's a practice problem. Draw a free body diagram and a net force diagram for a motorboat whose motor has just run out of gas. Okay, so let's do our picture here first. There's our boat in the water. Right? It's moving with some initial velocity, but the motor just ran out, right? So at some time later, we know that its velocity is going to be 0. And since there is a change in velocity, there must be an acceleration. Okay, so what are the forces acting on this? So let's draw our interaction diagram. We have a boat, and mostly it's interacting with the Earth. Okay, so they are interacting through gravity, of course. That's a long-range interaction. Then there's also a contact interaction. Okay, and that has two components. So there's two things, right? We know when the boat is even still, we know that gravity is acting downward, and there is some opposing force, right? That's caused by the interaction with the water that keeps the boat afloat, and that's the buoyant force. Okay, while it's moving, there's also a force from the interaction here, right, that's resisting its motion. That's what's actually going to be slowing it down. So there's a contact normal, and then there's also a contact friction. So the force of friction. Okay, so what does that free body diagram look like? So we just draw the boat. We draw the force. Maybe we'll draw this out here. The force of gravity acting downward. The buoyant force is equal and opposite, upward. And then there is this force of friction, or drag, whatever we want to call it. Okay, so we do a net force diagram. So let's start here. We do force of gravity. And we could add the force of friction and the buoyant force. So our net force goes from where we started, the tail of force of gravity, to the tip of the buoyant force. That's our net force.